Okay, let's solve getInRange. GetInRange is going to take three values, x, bound 1, and bound 2, and it's going to return the value x, but assuring that it's between bound 1 and bound 2, where bound 1 and bound 2 can be in either order. Let's look at some of these examples. So getInRange of 1, 3, 5 wants to return 1, but it's outside the range 3, 5, so it moves it into the range and returns 3. Fourth is between 3 and 5, so 4, 3, 5 returns 4. 6 is beyond the upper bound of 3, 5, so it returns 5. And finally, 6, when you change the bounds around, the way the problem is defined, 3, 5 is actually the same as 5, 3. 6 is beyond the upper bound, so it returns 5, the upper bound. Now that we understand this, let's actually solve it. So here we are, getInRange. Of course, 42 again is just a placeholder. So what we want to do is find first, we don't want to deal with bound 1 and bound 2 because we don't know the order. So we want to establish the order. We know that the low value is the minimum of bound 1 and bound 2, and the high value is the maximum of bound 1 and bound 2. Great. Now we don't have to worry about order. We know low is low. So if x is less than the, if x is less than the low value, that's right, pardon me. Now x is too small. So what we could do is we go ahead and say that we'll just set x equal to the low value. That brings it up to the low. If x is greater than the high value, we'll bring x down to the high, and then we'll just go ahead and return x. When we run this, we see that it works. Awesome. Let's actually do this a different way now. Oh, by the way, if you want, it's actually okay to indent this on the same line, to not indent, but place it on the same line. We allow this for if statements where the body, this part's called the body, is extremely simple. I think this counts. So I would say this is actually a valid way to answer this problem. Now, we're going to do this slightly differently. We're going to define it again. By the way, if you define a problem more than once, Python's going to use the most recent version of it. So if I put return 42 here and run, we'll fail because 42 was not correct. So we define this one and immediately define a new one. Why am I doing this? I'm just leaving it up here so you can see it. All right, so in this other way, what we're going to do is we are going to go ahead and say, you know what? The smallest value that we can have is the larger of x and the low value. That's the smallest value that we are allowed to have. If x is smaller than the smallest value, then the max of that low will simply be low. Turns out the largest value we can have is the minimum of whatever value we had and the high. In other words, if this value is bigger than our high, then the high will be used. And we'll go ahead and return that. And look, that actually works. All right, which of these two is better? Well, that's an exercise for the reader. You have to decide first which one works more correctly, and there it's a tie. They actually work the same. Then you can argue which one's more efficient. Well, really, they're both equally efficient, so that's not going to discern them. The most important distinguishing factor here is which one is clearer. I would actually argue probably the first one is clearer. I think it's clearer what's going on there. But I think the second one is reasonably clear too. So either one is a good answer, even though maybe you would argue the first one is better.